Up to this point, we have looked at two different types of distributions. We've looked at the normal distribution, which includes the standard normal distribution, and then we've looked at the t-distribution. So for the first time here, we're going to take a look at a new distribution that is called the chi-square distribution. And so we're going to talk about its properties, and then we'll look at when we're going to use it. So the chi-square distribution, we're going to use this Greek letter chi, and then it literally has a exponent of 2 there as squared. So chi-squared distribution. Some properties about it. So this curve is not symmetric. I know that the normal distribution we've learned so far and the t-distribution have both been symmetric. This one is not. It is going to be right skewed. Just like the t-distribution, a chi-square curve has a different curve depending on the degrees of freedom. Again, degrees of freedom is still going to be related to the sample size, but we're going to get formulas for the degrees of freedom for different types of tests later. So in general, I've just drawn you a couple examples of chi-squared distribution curves. The first one here has a degrees of freedom of 4. You can tell it is very right skewed looking. And then the other one that I've drawn has a degrees of freedom of 10, so that would be a larger sample size. And you'll notice that it is less right skewed. It's starting to look a little more bell-shaped. And that is a property of the chi-squared distribution. So our degrees of freedom, as those increase, our chi-square distribution starts to approximate the normal distribution or get closer and closer to that normal bell shape. And in fact, you can see down here in this bullet that when the degrees of freedom is greater than 90, that chi-squared curve very closely approximates the normal distribution. The other thing that we need to know here is that the test statistic for any chi-squared test is going to be greater than or equal to 0. You can see we actually have a 0 value here, and we increase to the right. And this is because the chi-squared random variable is made up of the sum of independent squared standard normal variables, and so that sum has to either be 0 or positive. You'll see those sums appear as we go through our examples later. Okay, so that's just a very brief introduction to the chi-square distribution, and then we will next go on to look at some specific tests.